Alright, this video is going to be about deriving the natural log function, and there's kind of an interesting proof that goes along with this, and we can prove how this derivative works, and we're going to do it in class. But I'm just going to post some of the basics in this video. Natural log, the natural log of x, if you want to derive it, so I want to find d dx of natural log. If you want to just memorize it, the general rule is that the answer is always going to be 1 divided by x. And that's the derivative of natural log. Now it's going to get tricky when I start changing the natural log and say, instead of natural log of x, I have natural log of, x cubed. Or I have natural log of 2x minus 4. Well, that's when the chain rule comes into play. So of course we're going to have some chain rule with the natural log. So this is kind of your most basic derivative. Here's what your chain rule is going to look like. Instead of deriving natural log, we're going to find d dx, the derivative with respect to x, of natural log of u. Where u is anything that I make up. U can be the x cubed, the 2x minus 4, or anything else we decide to kind of put inside of there. So the rule is, it's still like 1 over x, it's going to be 1 over u. But because of the chain rule, we have to add on a little extra, du over dx, to the end of it. And that's our chain rule piece. And I always tell people this is what you want to memorize. If you can remember this rule, chain rule with natural log, you'll be able to do a lot of different derivatives. And so I'm going to give you a couple of examples here, and then I'll have you take it from here. Alright, okay, so example 1 that I was going to show you is, suppose you have f of x equals the natural log of square root x, and I want f prime of x. So the basics here are u is the inside, it's the square root of x, and the derivative of u, du dx, is finding the radical. We use the radical rule to find it. So derivative of the inside is 1 over 2 times itself radical x. And so we're going to use the formula. The answer is going to be 1 over u times du dx. So let's plug in our facts. 1 over u is going to be, we'll start with this piece, that's going to be 1 over radical x. Times du dx, this piece, well, we just found that, 1 over 2 radical x. So f prime of x is going to be equal to these two fractions that are multiplied. You probably do not want to leave your answer like this. So I'm going to multiply it out. 1 times 1 is 1 over radical x times 2 radical x is just 2x. The radicals cancel. So f prime of x equals 1 divided by 2x. And there's my answer. A second example I wanted to show you is we can apply a lot of different things like product rule and chain rule and all the things that we've learned to natural log. So we're kind of seeing how the chain rule works. But let's imagine you have, maybe some other properties that you have to work with. So for instance, I have f of x equals the natural log of x plus 1. And then I have maybe the square root of x on the end of it. If you had to find this derivative, well, you're going to have to apply the product rule. You have a first and you have a second. So you're going to have to do the first times the derivative of the second. The first is natural log of x plus 1. The derivative of the second is the radical rule. We just did it earlier. Its derivative inside is 1 over 2 times itself. Plus the second is radical x times the derivative of the first. Okay, well, the derivative of the first, I'll make a parenthesis, is using the natural log chain rule. It's going to be 1 over u du dx. That's our formula. So 1 over u is going to be 1 over x plus 1. Du dx, maybe we should put a side note here, but if u equals x plus 1, du dx, the derivative is equal to 1. So I'm going to have 1 over x plus 1 times 1. And then this whole thing's going to make up my answer, so I'll clean it up. I'll combine this into one thing. I'll make it natural log of x plus 1 divided by 2 radical x plus this thing I'll combine into one fraction, radical x over x plus 1. And so f prime of x equals this answer. And I'm done. And that's how you use the natural log with the chain rule.